Hey guys, welcome back to part 2 of the quadratic formula and the discriminant lesson. Okay, in the first part we talked about where does the quadratic formula come from, which is from complete the square. And we talked about, my method might be a little bit different than what most people use to solve this, but it's going to come to benefit in the future, and we'll see that later. Today we're going to continue that conversation, and specifically we're going to look at one part of the formula that's pretty telling. That tells us quite a bit of information, okay? And it's called the discriminant. So if we're looking at this guy, this is our quadratic formula. The discriminant is this section underneath the radical. Okay, we call that part the discriminant. Just a basic definition of it, the discriminant is just some parameter that is able to tell you that when you're done with this calculation, how many solutions you should have. Okay, so this determines the number of solutions. The number and type. Sorry about that. Little extra thing. The number and type of solutions a quadratic will have. Full disclaimer. Quadratic isn't the only thing that has a discriminant, okay? Cubics have a discriminant. So it's just, I don't want to just resort that to just quadratic, but since we're talking about quadratics, we'll leave it like that, okay? Now, let's think about this for a second. Let's go off to the side here. I have 3 different types of problems. If we were to simplify something, let's say we get these 3 results. Looking at the first result, when the discriminant was a positive number, like let's say it was a square root of 16, then if I were to solve this, I would have, you can see it. I would have 5 plus or minus 4 over 2. And if I were to continue to solve it, I would get 5 plus 4 divided by 2, which is 4.5. 5 minus 4 divided by 2, which is 1/2. I get 2 real solutions for that guy. And incidentally, if we were to graph it, then that's telling me that my parabola is crossing the x-axis. Now, this is just a generic graph. I could be drawing it differently, right? It could be reflected instead. But the general case is I get 2 real solutions, okay, and it's crossing the x-axis for the graph. Now, let's look at this guy. Let's say we're simplifying the quadratic formula, and I get a negative value in here. Well, a negative value we know how to solve for. We talked about complex numbers. So that's going to be 5 plus or minus I square root of 7 divided by 2. Now, if I were to break this apart, I would get 5 over 2 plus or minus I square root of 7 divided by 2, which we talked about in terms of complexity and how do we break this up in the form of A plus BI. Previous lesson. Okay, if you haven't watched it, it's a great lesson. You should go watch that one. Complex numbers. It's a fun topic. So looking at this, if the square root or the discriminant was negative, we had 2 complex solutions. Okay, so we have 2 real solutions when it was positive, and now we have 2 complex solutions when it was negative. Now what happens if it came out to be 0? Well, if I were to simplify this, and I'm going to have to bring it down here, this square root of 0 is just 0. So it becomes 5 plus or minus 0 over 2, which is just 2.5, right? If I add or subtract 0, it's not going to change the numerator at all. So when this was 0, we have 1 real solution. Do you see how the discriminant is telling? All right? Do you see how that's going to let me know the number of solutions? It's not going to give me the answer, right? If I just calculate this portion, I don't get the answer to the quadratic. But at least I know ahead of time if I'm looking at something that has positive solutions, imaginary solutions, or just 1. Now, since I graphed this one, let's graph the other one. If this is 2 complex solutions, then that's telling me that my parabola never crosses the x-axis. So once again, general graph of what that would look like. Then down here, if it has 1 real solution, then that's telling me that my vertex has to be resting on the x-axis, okay, to only have 1 solution. Just remember from the previous stuff that we've done what those graphs look like, because I think right now we've connected everything, at least I think we've connected things pretty well. When we talked about the very beginning of quadratics, graphing them using a table, vertex, what does that mean? Where the negative b over 2a came from? We did that through some homework assignments. And then factoring, how does factoring work? How does complete the square work? And how's that changing the shape of the graph? And I think we've connected those dots quite nicely. So for today's lesson, we're only going to calculate the discriminant and figure out what type of solutions we have. It's not the answers to the quadratic, we just know what types. Okay? So let's just do a quick little table and then we'll do some examples. So based on just my little side conversation over here, if the discriminant was greater than 0, then we had 2 real solutions. Okay? If the discriminant was less than 0, we know we have 2 complex solutions. And then if the discriminant was exactly 0, we had 1 real solution. I don't know why I write the last one fully out. The other ones I abbreviated. I'll abbreviate that one too. Okay? Now, could you go a little bit more specific? Yes. Could you say if it's rational solutions? Just depends. Okay? We could break the real solution part down a little bit further. So for instance, if this was a perfect square, you're going to have some rational solutions, right? If it wasn't a perfect square, we could have some irrational solutions, right? So if you want to put like a sub thing, so 2 rational solutions if b squared minus 4ac was a perfect square. I guess we could include that. A little subclause mixed in with there. All right. Okay, let's go ahead. And we're going to just try out 2 examples. Okay, nothing too difficult here, but just to practice using the discriminant. And give me one moment. I got to find my examples. I apologize. Here we go. Okay. Now, what I'm going to do, I want to keep this off to the side. So I am going to bring a new whiteboard over here. And we're just going to move the camera a little bit. Perfect. Okay. So you can see if they have tests or quizzes today. If you're watching this video and you're in my class, hey, there's a test and quiz coming your way. Example 1. X squared plus, x squared minus 11x plus 10 equals 0. Okay? And all we're going to do, we're not going to solve it. I want to know how many solutions it has. Okay? Is it real, complex, or just one? One real. So we're going to go ahead and just use the discriminant. Okay? Now, go ahead. If you want to lay out what your A and B values are, that's not a bad idea. My A value is 1, my B value is negative 11, and my C value is 10. Remember, it's just the coefficients in front of the quadratic and linear term, and your constant, which is always the C value. Substitute. So we have here negative 11 squared minus 4 times my A value times my C value. Okay. First part will give me 121 minus 40 when I've done multiplying the other side of this. And we get the discriminant to be 81. Now remember, that's not an answer to this guy. You have to be careful. So a positive 81. So since the discriminant is positive, that's telling me I have 2 real solutions. So therefore, I'll put the little dots there. Therefore, we will have 2 real solutions. And that's it. Okay? It's almost like you're looking into a crystal ball and you're trying to predict what this quadratic has. And it's pretty cool that we can figure out what that is ahead of time. But hey, not too bad, right? Let's do one more example. x squared plus 2x plus 7 equals 0. Correction. Let's do 8x plus 16. I'm going to switch it. Sorry. If you wrote that down ahead of time, I apologize. Locate the a, b, and c values. So a is going to be 1, b is 8, c would be 16. Substitute. We get 8 squared minus 4 times 1 times 16. 8 squared is 64. 4 times 1 times 16 gives me 64. Therefore, my answer is going to be 0. That's what's going to be underneath the radical of the quadratic formula. 0 is telling me that I will only have one real solution. Okay? Therefore, one real solution. And if you remember, graphically, that's pretty much telling me that it's resting on the x-axis for it to have one real solution. And general graph, not the graph of this guy. Full disclaimer. That's it. Okay? That's the discriminant. A very powerful little tool. Like I said, no answers, but it tells me what type of answers. And that's honestly pretty important if you think about it. If I want to just graph this, and let's say I just want to see real quick if my graph's accurate. Like if I'm graphing it and I'm like, did I graph this right? I don't know. Find the discriminant. That's going to tell you how many solutions. So if your parabola, is not crossing the x-axis, but according to this thing it should, well, you did something wrong. You got to make one little change. Okay, that's it. Hope you guys are doing well. I hope this helped you a little bit. If you have any questions, let me know. My notes are uploaded for you, and it has a lot more examples in case you need that more practice. But until next time, guys, thank you, and I will see you all in the next lesson video.